In this video, we are going to take our ability now to do a 2's complement and actually put it into some subtraction. So we've talked about computers cannot subtract, okay? But to review very quickly, we're going to take the 2's complement of the subtrahend and add it to the minuend, which we showed that if we're going to subtract, that's the minuend, that's the subtrahend. We're going to take the 2's complement, add them together, and that's going to give us the value, okay? So again, a little bit of repeat here because I want you to really get it, okay? But we're going to take the 2's complement of this number and add it. So now let's see this in action and try a couple examples. Subtraction. Now we're going to start with 12 minus 8, okay? Spoiler alert, should come out with a 4, okay? Even when I do this on an exam, I give you the base 10 and the result is something simple so that you can demonstrate that you know how to do it. It's about me knowing that you understand the process. The math itself should be simple, okay? All right, so 12 is 8 and 4. So that's the 8 and the 4 bit that are set. We need to know the 2's complement of the 8 so that we can add it. Okay? So we need to know the 2's complement of the 8 before we can go anywhere. So somewhere else, we're going to calculate that. So we're going to go to what we did before and say, flip the bits and add 1. So we're going to put the 8, okay, which is just the 8 bit is set. All right? We're going to flip the bits, which is pretty easy in this case. All right? That's pretty easy in every case, but we're going to add 1. Now, this time the add 1 becomes a little bit more work, okay? So let's go through it. Here we go. 1 and 1 is 2, so that's a 0 with a carry. 1 and 1 and 0 is a 2, so that's a 0 with a carry. Another 0 with a carry. That's going to just drop down, and now because these are all zeros, these 1s are just going to come down. Okay, we're done carrying. Now, when you do a 2's complement, you should expect to see a lot of 1s in the left nibble. Because we know that we're going to float 1 off the end like we said before. So we're expecting to see something that would, in our minds, tend to lead us to believe that one of the bits is going to float all the way off the end. Okay, so if you don't see a lot of 1s in the left nibble, okay, or at least 1 over here, all right, you might want to go, did I do my 2's complement right? All right, now again, left nibble, right nibble for ease, all 1s and 1,000. Okay, so we're going to go back to our equation now, and that is the 2's complement of 8. And we've got our 12, and now we're going to put the 2's complement, which is all 1s and 1,000. So that is the 2's complement of 8. And now we're going to do the addition. Okay, so 0, 0, 1. 1 and 1 is 2, so we're going to get a carry there. And now you're going to see what I call the floating off the end pattern. Okay, because we're going to keep carrying, because we got that 1 carry bit into this nibble, and it's just going to float itself all the way to the left. So watch as I do this. That's a 2, so that's a 0 with a carry. 0 with a carry, 0 with a carry, 0 with a carry. Now if this wasn't subtraction, that would be a problem if we didn't have another register to go to or another byte to go to. Okay, but this is a subtraction, so we expect that to go off the end, and the result should be left in the register, which is the 4 bit, which is the correct answer. Okay, that's all there is to it. We're going to add the 2's complement to that. So this is kind of the negative version, the digital negative version of 8. And it's going to float a bit off the end and leave the result of the subtraction on the register. Okay? And that is how that works. So adding the 2's complement gives us the result remaining on the register. We ignore the carry bit off the end. That's expected, and we just ignore that carry bit. Okay? That's how it's done. That's how a computer subtracts. So now let's do one that's a little bit more complicated. Let's take 25 minus 11, and again, spoiler alert, we should see 14. All right, so 25 is the 16 and the 8, which is 24, plus the 1 bit. So that's 25. And we're stuck again. We need the 2's complement of 11. All right, so that is what we're going to need to complete this subtraction. So we're going to go somewhere else on our piece of paper, and we're going to flip the bits and add 1. Okay, so we're going to start with 11, okay, which is 8 and 2 and 1. 8, 9, 10, 11. Okay, so the bits are set. We're going to flip them. So that's all 1s, and the 1, 0, 1, 1 becomes 0, 100. Okay, now adding 1 in this case is fairly trivial, okay, because they're all just going to come down. There's no carries in, whoops, yeah. We're just going to keep going. There we go. And they're going to keep going. Okay, so all 1s, and then 0101 is the 2's complement of 11. So let's go back to our original problem, where we've got 25 minus 11, we're looking for 14. So 25, okay, we've seen that before. Now it should be all 1s and 0101 as the 2's complement of 11. So now we're going to add them, and once we're done adding them, we should, again, carry 1 off the end, and you can kind of see it looks like we're set up to do that, okay? But we're going to hopefully float 1 off the end and have the result, which we're expecting to be 14, left on the register. So here we go. Let's see what we get. 0 with a carry. That 1's going to just drop all the way down. Now there's just a 1, and there's just a 1. So in this case, we didn't float anything into the left nibble, did we? But the left nibble is set up to do its own float off, okay? So sometimes you'll see it both ways. It's just a matter of what's the value in the middle. All right, so 1 and 1 is 0, carry the power. Then we're going to do it again. Then we're going to do it again. Then we're going to do it again. And it's going to float off the end. Okay? Now, did we get it right? We floated 1 off, and we've got 8 and 4 and 2, which happens to be 14. So we got it right. Okay? So, once again, adding the 2's complement gives us the result remaining in the register. Okay? And we've sailed that 1 bit off the end, but we know about it, so we don't care. Okay? And that is the extent of the binary math that we're going to do. We've done a simple addition. We know how to take the 2's complement of a binary number, flipping the bits and adding 1. And we know that if we add that to the number above, we get the subtraction of the 2. And we've done it by floating 1 off the end and having the result of the subtraction left on the register. Okay? That is what you need to know for IDT for binary math. Okay? Now, in the next video, we are going to begin to become more and more like programmers. Okay? We're going to start with web pages. Now, I tend to be a little bit of a stickler. I don't believe that it's correct to say you program in HTML and CSS because those are file formats. Okay? But developing HTML and CSS pages is structured formatting of content, of a file, okay? And when you get into CSS, it's almost like programming statements, okay? The way you do styling with semicolons and braces, and we're gonna get into all of that in the next series of videos. The other side of this is, it's just really cool. Being able to develop your own web pages, and we're going to do it with nothing but Notepad++, which is a simple text editor, and a browser. So we're going to build web pages literally from scratch, okay? Because it's important to me that you be able to do this from nothing, because it will help your confidence, and before long you'll be like, oh, this isn't that hard, and you'll be off to the races. And being able to build good web pages is, I think, a very good foundational skill for programmers, because more and more coding is being done around web experiences. In fact, in my later courses, when we get into talking about Microsoft C#.NET Core, it is beginning to blur the lines between web pages and code. You can actually put C# code now in an HTML file, okay, in a web page. So the lines are blurring, but for now we're going to be beginners and purists about it, and we're going to understand that HTML is a file format, and CSS, Cascading Style Sheets, is a file format. They are not programming languages. We are not programming yet, but we're getting awful close to it, okay? And so we're going to learn syntax skills and how to be careful with what you're doing. And this is a really cool unit. If you've never built web pages, it's great. If you have, we're going to kind of break it down from the beginning so that if you've developed any bad habits, we clarify them. And I mean, even to this day, I will go back and look at, is there anything new that I'm missing in the fundamentals? Because if you have good web development skills and build good discipline from that, taking that into a programming language where you're actually writing code and logic, it's a smooth transition if you have good HTML and CSS skills. So it's kind of a bridge for me, the way I use it. But it's also really good if you're going to build web pages for any FBLA or DECA or any other CTSO content. It's just really good to be able to do. And if you ever run a business or want to be a web developer, I mean, there are so many jobs right now where good web designers and web developers are needed. So it's its own career path within information technology and computer science that you may get into this and go, wow, I could just do this, right? So pay attention to it. It's a really good unit, and we're gonna kind of take it from ground zero and build from there. So if you've never done this, you're gonna like this because we really do make it simple, okay? And we start with the very basics, and then we'll grow from there. And then you'll know enough to just go play with it on your own. And that's really the cool part about the way I teach these courses is I want to be kind of the ignition on the rocket, and then I want you to be able to catch fire and say, oh, I'm going to play with this, I'm going to play with this, I'm going to play with this. And the more you experiment and the more you spend time doing this, and what I call committing the act of computer science, the more fun you're going to have and the more you're going to be creative. And if I can get you to where you are beginning to be inventive, then I've really done my job. Okay? So this is all you need to know for the binary math. Simple addition, 2's complements, and simple subtraction at the 1 byte level. That's it. Okay? So we're going to move on in the next videos to understanding HTML and styling. And it's just, I think you're going to have a really good time. So I will see you on the other side.